So this is solving equations with variables on both sides. Hey, let's go. Basically what we're going to do is, it's not that much different than what we've done prior to when we solve any other variables or solve any other equations. The only difference now is that we have to get the x's together. And that's a new step that we're going to have, but that step is going to be the one that we do first anyway, so it's not a big deal. Okay. Just want to give you some quick steps on that. So your first step is draw the river. And guys, some of you guys that are working in tutoring, or I see you just doing different stuff on your paper, you're not drawing this river and then your work gets disorganized. Please understand this. Okay, I am very flexible about the way you learn things, about the way you approach problems. I don't care how you do it as long as it's logical. Now, the one thing I am concerned about and the one thing I am picky about is being organized. Because what you don't know, because you're a 9th grader in Algebra 1, is that by the time you get to Algebra 2, you're going to have pages and pages of problems. And it needs to be organized. And some of you guys, you just do the little simple basic arithmetic on the side. You can't do that. You've got to keep this organization. I have 6 students or 7 students that went to pre-AP geometry out of Algebra 1, which is abnormal. That's not a normal thing for students to do, to jump out of a regular class to go into a pre-AP math class. I have 7 students, all of which are still in there, all of which are pretty successful. And the reason I'm telling you that is because all of those students, they listen to what I said about being organized, and so they basically try to do exactly what I do. That's a pretty good rule of thumb. You know, if you want to be the best at something, pick the person who's really good at it or the best at it and do what they do. I mean, it's that simple. But some of you guys still just try to do all your little simple arithmetic, and then you're going to start finding out you're missing little points here and there, and that's frustrating when it comes to math. When you know how to do the work, but you miss it because you're not taking the time to show all of your work or do the steps in a very organized manner. Okay, so the first thing you want to do is draw the river. The next step is get x's together. And the next step is simply to solve. Okay, now these are 3 very abbreviated steps. But the reason I wanted to give you these steps is so that you know to get the x's together first. Okay, now we're going to go through the process of how we do that right now. Okay, but we're going to do that through examples. So our first example is 7x plus 19 equals 2x plus 55. So now you can see that you have x's on both sides of the equal sign now. Or if we draw a river like we're supposed to, we have x's on both sides of the river. Now, the first step is after you draw the river, is to get the x's together, okay? So I need to get the x's on both of the same side of the river. We do this by moving the smallest x first. Okay, so I need to move the smallest x first. Well, which one's the smallest x? 2x. Now, how do I move that to the other side of the river? I subtract 2x, okay? Because remember, I've got to make it 0, 0 on this side, so I can move it on to the other side. So I subtract 2x from both sides. This cancels out here, which is why I did that. 7x, look at it. If you do this other line here, which when I first started teaching, I didn't teach this other line, but when you do this other line, you can actually see the problem. 7x minus 2x, just like elementary school. What is 7 minus 2? 5. So now I have 5x. I didn't do anything with the 19. There's nothing under the 19, so I just simply bring the 19 down. So 5x plus 19 equals 55. And now I have a normal equation that I should be able to solve for. Okay, but again, like I said on that Unit 4 test, it didn't look very pretty. Okay, so make sure you continue to pay attention to how we solve the entire equation. So now I just got to get everything away from the x. So how do I get everything away from the x? Yeah, do the opposite. Again, subtract 19 from both sides. And again, this is a subtraction problem, so I'm going to go ahead and draw another line. Didn't have anything underneath the 5x, so I'm just going to bring it down. So that leaves me with 5x. Those cancel out. Equals, what's 55 minus 19? Okay, equals 36. Okay, and then I divide both sides by 5. And I get x equals, can I reduce that? No, so x equals 36 fifths. And do not be afraid of a fraction answer. If I divide that and get a decimal, is that simplified? No. A fraction is the same thing as a decimal. Fractions and decimals are the same. So don't divide that and say, oh, I need to simplify it, I need to put it into decimal. If you don't start with the decimal, you don't finish with the decimal. So we didn't start with any decimals, so we're going to finish with a fraction. Okay? Now, everybody that has a calculator, because you were smart enough to pick one up on your own, okay, do 36 divided by 5 in your calculator. Because maybe you don't know it reduces. Maybe you're not sure. So do 36 divided by 5 in your calculator. What do you get? 7 point something, right? So now, you said, you know what? Mr. Melvin said leave it as a fraction. So I need to turn it back to a fraction. So do math, enter. What do you get? 36 fifths. So now you can be confident in knowing that that is the reduced form. Because when you do that math, enter, your calculator would have put it in the lowest possible form, the most simplified form. So this is now simplified, so you know that. So essentially what you did was you took it into a decimal, turned it back into the same fraction it was because it can't go any lower. Okay, so that's our answer. Any questions on that? Yes?
Would it be wrong if we do a decimal?
Okay, again, it necessarily wouldn't be wrong, but the rule of thumb is if you don't have a decimal, don't finish with a decimal. Just follow that rule of thumb always, okay? So if it starts with a decimal, then you finish with a decimal. If it starts with a fraction, you finish with a fraction. If it deals with money, you do a decimal, 2 places. Okay? And a good rule of thumb is if it doesn't tell you how far to round, I generally round either 2 or 3 spots, so hundredths or thousandths spot. Okay? But read the directions to make sure you find out what it's actually telling you to do. Okay? Does that help? Okay. Now again, what's funny about this is right here, whoops, not that. Students always want to divide and put it into a fraction, a decimal. But that's one more step. You're done right here. The next step would be to divide. Why do you want to do extra work? Don't do the extra work. Plus you have a chance of screwing that up because what if you accidentally put 35 in there? And some of you guys round to the whole number, which is wrong. You don't want to do that. Okay? All right, let's look at our next example. We have 16 minus 3x equals 11 plus x. Good grief. Okay? As always, first thing I want to do is draw the river. Then what? Okay, what do I want to do? What did I put in parentheses on the last slide? I want to move the smallest x. What's my smallest x here? Negative 3x. Is it negative smaller than positive? Just grab that desk. It's all right. So negative is smaller than positive no matter what. So negative 3x is the smallest x. Yes, sir.
If you use a bigger number, will it still be wrong, or is it still going to be right?
That's a great question. If you use a bigger number, will it still be right? It will still be right, but it'll be extra work, and I'll show you that here in a second. So let's move the smaller one first, though. Okay. So we're going to move the negative 3x by doing what? So we're going to add 3x to both sides. In fact, here's what we'll do. We will do it on both sides. I just set it right in front of Emily. Alright, so we're going to do two problems at one time. Same problem. 16 minus 3x equals 11 plus x. Because that's a great question. So we're going to accidentally move the bigger x instead over here. Now on this side, this cancels out, leaving us with 16 equals what? 11 plus 4x, right? And here's what you're about to see is where we're going to have some problems with moving the bigger x. Okay? What's over on the left side of the yellow equation? 16, right? That just comes down. So 16 minus 4x, but a lot of people will put 2x there. So 16 minus 4x equals 11. Okay, let's go back to our other problem. What do I do next over here? Subtract 11 from both sides. That gives me 5 equals 4x. Go back to the other side. What do I do over here? Now I'm subtracting 16. So essentially I'm doing the opposite of what the other problem is doing. That cancels, leaving me with negative 4x equals, don't forget to bring that negative down because that's another problem that students forget. Notice that this is negative 4x. You've got to bring that negative down. And that equals what? Negative 5. Okay, go back to the left side problem. What do I do over here? Divide both sides by 4. That cancels. That leaves me with what? 5/4, right? Can it reduce? No. So there's my answer there. Okay, let's go back to the right problem. What do I do there? Divide by negative 4 now. Does this one reduce or simplify? Yes, to what? 5 over 4, right? Because the negatives cancel out. So to answer Luke's question, did we get the same answer? Yeah, we sure did. The only thing is you're dealing with a negative at the end. And so that the x value will always be negative until you get rid of that negative. And so what a lot of students will do, and this is a good example because you have the negative 4, so it's easier to get rid of. But some students will forget when it says minus x. Some students will forget to take the minus x all the way down. And then what happens is you have a negative x equals. So all you have to do is change the sign, and we'll see one of those later. Okay? All right, any questions on that one? So far, it's really not a whole lot different except for moving that 1x first, right? And also, just to kind of get on the train that Luke was on, just asking about the other side, could I move the numbers first? Sure. You could wait till the end to move the x first, but again, you always want to move that smallest x first. What does that do for you? What do we just see? What does moving the smallest x do for us? It makes it easier. It's less work because what does it do to my x value? It keeps it positive. It keeps that x value positive. Okay? So that's why we move the x value first, so we control it and make it positive. Okay? All right, let's look at another example. So example 3, we're going to do a lot of examples only because, again, I have little confidence right now about your solving, and I want to make sure we get it all covered. Okay? So now we're going to do 2x plus 3 times 4x minus 3 equals 8 minus 3x. Okay, there's our river. What do we do first now? Yeah, anytime you have parentheses, you want to get rid of those parentheses ASAP. So I need to distribute first. Draw my arrows indicating where I'm going. Did I do anything with the 2x? No, so just bring it down. So now I have 2x. What's 3 times 4x? 12x. 3 times negative 3? Negative 9. Again, some people are losing their sign right here whenever we distribute. Make sure you pay attention to that sign. Okay? Did we do anything on the other side? No. So just bring it down. 8 minus 3x, right? What's next? You're one step ahead. Combine like terms. Combine the 2x and the 12x right here. That gives us 14x minus 9 equals 8 minus 3x. Okay, now, Bray, what do we do? Now I'm going to move the smallest x. Which one's the smallest x? Negative 3. So how do I move it? Add 3x to both sides. What does that leave me with? 17x. Go ahead and bring down your what? Minus 9 equals 8, right? Because that cancels out. Now we have a simple problem. Now what? Add 9 to both sides. That leaves us with? Okay. Now what? Divide both sides by 17. And you end up with x equals 1.
Would they accept the answer as just x since x?
Would they as a me they?
Okay, yeah. Would you accept the answer as x since x is understood?
No. Oh, okay. I'm glad you brought that up because it comes up every single year. Hang on. I'll get to you in a second. She said, would they accept the answer as just x? Because x is understood to be 1. X is not understood to be 1. What is understood is that if you have an x, okay, if you have an x value, that is the same thing as 1x. That's what's understood. So what's understood is this 1 right there. Okay, x, and a lot of students think that. A lot of students believe that x is always 1. If you just have x, it's just 1. No, that's not the case. X does not equal 1. X equals whatever we want it, or whatever we make it to be. In the last case, x equals 5/4. In this case, x equals 1. What I mean by understood 1, that means that if you ever are given an x, that means you have one of them. You understand that you have at least one. It's the whole concept if I say, hey, do you have a penny? Okay, can I borrow a penny? Very rarely do you hear students say, may I borrow 1 penny, please? Okay, it's a penny. Do you have a car? Do you have a dollar? It's not, do you have 1 car? Do you have $1? Okay, now some people will say that, but you see I'm getting at that A. We understood the A meaning 1. You only want 1. If somebody asks you for $1, you're not going to give them 17. You're going to give them 1. And they're going to be like, dude, I need 5. Well, you said $1, right? So I gave you the $1. Okay? So that's what that means. All right, good question. Nathan.
Is it okay if I subtracted or added 3x to the other side of the equation before it's distributed? Sense?
Yeah, okay, great question, too. Again, math is awesome in the fact that you can go about it different ways. We just show you, or I, so you got me saying we and they now. Okay, I just try to show you the best, most efficient way that'll work every single time. You could have added 3x to both sides first and stuck it out here. That would have been okay, and then distributed it where it worked out. Okay, it would have still worked out okay. Okay, does that make sense? You could do that. It's just not normal. It's not as normal. You generally want to see the distribution first. All right, any other questions? Whatever you're most comfortable with, as long as you get x equals 1, it's fine. And again, even if Nathan does what he was talking about, he'll still have the same organized work. Okay? Again, the biggest thing I'm a stickler about is the organization. If you say, you know what, Mr. Melms, I always want my x on the left side, because there are some people like that. I always want x on the left side. I don't care which x is bigger or smaller. I just want my x on the left side. That's okay. If that's what you want to do and that's how you feel comfortable solving, fine. The organization is still going to be the same. Your method might be a little different, and that's okay. Again, the most important thing is the result based on work that makes sense. Logical work. Result based on logical work. Everybody get that? All right, let's go to another example. 2 more examples, and then we're done. Okay, so now we have an ugly problem. X minus 4 over 5 equals 2x minus 1 over 3. We're going to do this 2 different ways also. Yes, ma'am. Oh, thank you. Thank you. Okay, we're going to do this one 2 different ways as well. I like to give you as many ways to look at problems as possible so that you can find whatever's comfortable for you. Okay. Here's the first way we're going to look at this. There's a very easy way and there's a simple way. The easy way, in my opinion, is to understand that when you have a fraction, you can just simply cross multiply. Butterfly. You guys remember butterfly? Back in the day? Same thing. Okay? You can do the same thing here with this. This way and this way. So if I did that, what's my problem going to look like? 5 times 2x minus 1 equals 3. Okay, 3 times x minus 4. Okay, so that to me is the easiest way. You have 2 sets of distribution problem. It's no big deal. Okay, so we're going to go ahead and continue to work this one out. So what's the first thing I need to do after drawing the river? Distribute the 5. And I get what? 10x minus 5. Okay. Can I go ahead and distribute? Sorry. Yeah, let's go ahead and distribute. Let's do both of them at the same time. So equals what, Savannah? 3x minus 12. Okay. Now what? Now we're in a problem that we've been working on, right? So now what? Okay. Move the smallest. Subtract 3x from both sides. And again, you could have subtracted 10x if you wanted to. It didn't matter. But I like to teach you the smallest. And that gives you 7x minus 5 equals what? Negative 12. Now what? Add 5 to both sides. What do I end up with now? So 7x, that just comes down, equals 7. Now what? Divide by 7, and x equals 1. Okay? Oh, it was negative 7. Thank you. Yes, back here, I just put 7. So negative 12 plus 5 is negative 7. So I change it right there. And then negative 7 divided by positive 7 is your negative 1. Okay? Do you have a question? No. Okay, now I want to show you this other way, and it's a little more complicated, but for you guys that are upper level thinking, you'll understand this. But here's what I want to do. I want to show you how to get rid of fractions. Because yeah.
I was going to ask, I don't know my calculator, I can't see, so that's negative 12 plus 5, and that is a negative 7, right?
Yeah.
That's what equals.
Yeah. I want to show you how to get rid of fractions. And so, this doesn't help me because I can't always butterfly. That's not, I mean, I could, I guess, but I don't always want to do that. Sometimes I just want to get rid of the fraction. So one way we can get rid of fractions is multiply by the denominator. We've talked about that before, right? Okay, so watch this. And again, this is a more complicated way, but it'll kind of give you in the practice of multiplying by the denominator. So the first fraction I want to get rid of is what? First fraction I want to get rid of is what? So I want to get rid of that 5, right? So what I'm going to do is multiply everything by 5. When I multiply x minus 4, this part over here, by 5, what happens? Correct answer is the 5's cancel out. That's all that happens. 5's cancel out. So that gives me x minus 4 equals, okay? Nope. This is just like saying 5 over 1. So then what does it become? 10x minus 5 over 3. Okay, so I distributed this 5 here and here, and then I multiplied the 1 by 3, right? Because when you multiply fractions, you multiply straight across. Now, I still have a fraction. How do I get rid of that fraction? Yeah, multiply everything by 3. What happens on the right side here? The 3's cancel out. That's the thing I want you to understand. That's how you get rid of a fraction. Okay, the 3's cancel out. They cross cancel out, leaving me with 10x minus 5 on this side. And then what happens on the left side? 3x minus 12. Looks awfully similar to that step right there, doesn't it? It's on different sides, right? But essentially, I'm going to get the same answer. You guys see that? Okay, I wanted to show you that, and we're not going to go any further because you guys surely can rationalize they're going to be the same, right? Okay, but I wanted to show you that because here, this isn't always, you don't always get that luxury of saying, oh, it's easy to see cross multiplication. A lot of times you get one fraction, and you have to figure out how to get rid of that one fraction. But multiplying through by the denominator will cancel out that fraction. Okay? And it all works out the same. And we'll do more practice on that later. Okay? All right, any questions on this? All right, last example. And you really need to see this one. Not today, but we can do that in tutoring. Oh, I mean, we won't have time today because I want to show you this one first because you'll freak out if I don't show you this. Okay? 1 minus 3x equals 2 minus 3x. What do I do first?
Add 3.
Okay, add 3x to both sides. What happens? And you get 1 equals? No.
1 equals 2. 1 equals 2.
1 equals 2. Does that make sense? No. No, right? Does 1 equal 2 make sense? No, 1 does not equal 2. In this case, you have no solution.
I was thinking about the question.
Now, if you do the exact same thing, and the x's cancel out, and it says 1 equals 1, that makes sense. If your answer makes sense, or it says 4 equals 4, your answer would be infinitely many solutions. Okay? So, if we did this right here. Let's say we have 2x minus 5 equals 2x minus 5. What do you mean, favor? Just tape one of those drawers like a duct tape or something, blue tape, it's in a bottom drawer. Will you take this? back so that people don't trip over it. Okay, let's say we have 2x minus 5. I thought they had a more intricate one, but they don't. 2x minus 5 equals 2x minus 5. Okay? If you have that right there, you subtract 2x from both sides, theoretically, right? You end up with negative 5 equals negative 5, right? And that's logical. So then it would be infinitely...
Is there any like?
There's no symbol for that. So that'd be infinitely many solutions. Okay, because you've canceled out the x. Now, what does infinitely many solutions mean? This is the last thing we're going to talk about. What does infinitely many solutions mean?
They can have multiple.
Yeah, so if I put 1 in there, 2 times 1 is what? 2. Now remember, when I solve for x, I can put the x value back in and it should balance on both sides. So 2 times 1 is 2, 2 minus 5 is negative 3. Over here, if I put 1 in here, 2 times 1 is 2, 2 minus 5 is 3, that's negative 3. So negative 3 equals negative 3. It balances, right? What if I put 75 in there? Okay, 2 times 75 is 150, minus 5 is 145. 2 times 75 is 150, minus 5 is 145. It balances. No matter what number I put in for x, it will work. That's why you have to be careful, because students that check their work, which is a great thing to do, they'll say, oh, well, I checked my work and I got 5 to work. And then somebody else will say, well, I checked my work and I got 7 to work. Yes, because it's infinitely many. No matter what you pick, it'll work. So we follow that? All right, so here we go. So that's it. Your homework tonight is this worksheet.